Hello guys, I hope you're doing very well. Today we are going to complete the knowledge on partial fractions that we started in the last video. So, off we go. Let us consider the following integral. The integral of 3x squared minus x minus 5 divided by x cubed plus x squared plus x. Now, the denominator can be factored as x times x squared plus x plus 1. Nevertheless, the expression x squared plus x plus 1 cannot be factored any longer because it doesn't have any real roots. Thus, the expression 3x squared minus x minus 5 divided by x cubed plus x squared plus x can be written as a over x plus bx plus c divided by x squared plus x plus 1 by using partial fractions. So, if we multiply both sides of the equation by x cubed plus x squared plus x, we end up having that 3x squared minus x minus 5 is equal to a times x squared plus x plus 1 plus bx plus c times x. Now, if we notice that if x is equal 0, we can solve for the variable a, and we end up having that a has to be equal to -5. Now, let us consider the following two substitutions, x equal 1 and x equal -1. If we do them, we end up having the following two equations. 8 plus 4 equals b plus c, and 8 minus 4 equals b minus c. From the first one, we get that 12 is equal to b plus c. And from the second one, we end up having that 4 is equal to b minus c. And we have a system of equations with two variables and two equations. Thus, we can solve for each variable. If we do so, we end up having that b has to be equal to 8 and c has to be equal 4. Thus, the original integral will be equal to -5 times the integral of the x over x plus the integral of 8x plus 4 divided by x squared plus x plus 1. This will be equal to -5 natural logarithm of x plus 4 times the integral of 2x plus 1 divided by x squared plus x plus 1. But if we do the substitution u equals x squared plus x plus 1, its derivative will be equal to 2x plus 1 dx. Thus, such an integral will be equal to 4 natural logarithm x squared plus x plus 1 plus c. Therefore, the final result will be equal to the natural logarithm of x squared plus x plus 1 to the power of 4 divided by x to the 5 plus c. If the irreducible factor has multiplicity greater than 1, then we have to proceed in the same way that we did in the previous video. So let us consider the following. Let us consider the integral of 2x cubed minus 3x squared plus 11x minus 5 divided by x squared minus x plus 3 squared. Now, the expression in the denominator is irreducible, and it has multiplicity greater than 1. It's equal to. Thus, by using partial fractions, we can express this proper rational function as ax plus b divided by x squared minus x plus 3 plus cx plus d divided by x squared minus x plus 3 squared. Now, we need to find out the exact values of a, b, c, and d. The way in which we do this is exactly the same way as we did in the previous case. If we do so, we will find out that a is equal to, b is equal to -1, c is equal to 4, and d is equal to -2. I challenge you to check these values. Thus, the original integral will be equal to the integral of 2x minus 1 divided by x squared minus x plus 3 plus the integral of 4x minus 2 divided by x squared minus x plus 3. If we apply substitution, we end up having that those integrals will be equal to the integral of du over u plus 2 times the integral of du over u squared. Thus, those integrals will be equal to the natural logarithm of x squared minus x plus 3 minus 2 divided by x squared minus x plus 3 plus c. And this will be the final result for the original integral. I challenge you to use partial fractions for solving the following integrals. And as usual, see you in the next lesson.